Good morning, Dr. Imran.
Morning, thank you for joining. Okay, Bismillahirrahmanirrahim. Assalamualaikum and very good morning. Everyone can hear my voice? Assalamualaikum and very good morning. Everyone can hear my voice? Okay, thank you for the response. Okay, welcome to SSE Research Knowledge Sharing Webinar, series number 8. Okay, before that, I have a few announcements. Okay, participant, please chat in chat box, our chat box or chat room. You need to fill up 2 Google Form. Google Form number 1 is registration form for certificate purpose, and the second Google Form is evaluation form. Okay, the evaluation form is important because to improve our webinar in future. Alright, and here I have one announcement. Okay, all participants are not allowed to post or present anything considered unethical material. Okay. Alright. Before we start, can all participants turn on your camera first, so we can screenshot our face lah. Okay. For a while. Please turn on your camera.
Okay, everyone is ready. Okay, 1, 2, 3. Hold on. Okay, one more time. Okay, 1, 2, 3. Okay. Okay, thank you very much. Okay, Imran.
Okay, thank you everyone for your cooperation. Okay, before we start, allow me to introduce our honorable speaker. Okay, our speaker today is Associate Professor Dr. IMRAN AHMAD. He received the Bachelor Engineering degree in Electrical and Electronic Engineering from Universiti Technology Malaysia in 2003, and received Master degree in Electronic System Design Engineering from Universiti Science Malaysia. In 2013, he received the PhD degree in Computer Vision from the Newcastle University, United Kingdom. Okay, he currently associate professor with the School of Computer and Communication Engineering, Universiti Malaysia UniMAP. Currently, his research interests include biometric, statistical, signal and image processing, and pattern recognition. Okay, he has extensive portfolio of the relevant research supported by the variety of funding agency for local and international. He also actively participate in international conference as workshop and serve on the organization as chairman, vice chairman, and technical committee. In addition, he acts as the consultant to a number of industry companies that involve the use of computer vision technologies. So without any ado, please Dr. Imran give his speech. Okay, one more thing. All participants need to turn off your mic because to get your we can hear our speaker voice clearly. Okay, please, Dr. Imran.
Dr. Imran, are you okay?
Sorry, PM Dr. Imran, we cannot hear you.
I think he forgot to turn off his mic. Just wait, just wait.
Ya, Ilman.
Okay, Dr. Imran, boleh dengar?
Boleh ya? Okay.
Boleh.
Sorry.
It's okay.
I'm not sure what's the problem with my laptop. Okay, never mind. Just now I put the volume to the maximum level, so now I try to reduce the level. Okay, never mind.
We can hear your voice
Right. Sorry.
clearly.
Yeah, just clear. Okay, never mind. Let's start again.
Okay. Hello guys, everyone can hear my voice? Okay, thank you for the response. Okay, I think our speaker restart his laptop. So I hope all participants still in here and give some time to our speaker to ready that. Okay, thank you for your cooperation.
Okay, boleh dapat ya, Inman?
Boleh dengar.
Dengar? Okay, slide nampak tak slide?
Slide pun nampak clear. Thank
Okay,
you.
right. Okay, right. So this is the title of my talk. Okay, the role of biometric during post-COVID-19 era. Based on this title, so you can see two of these words, biometric and also post-COVID-19. So now I try to find the correlations between COVID-19 and also the biometric technology. So nowadays, if you can see, the COVID-19 give the effect to the application of biometric technology in our daily life. For example, before this, we have thumbprint sensor. Thumbprint sensor or fingerprint sensor we use in the attendance systems. And then after the COVID-19 pandemic, we are not allowed to use this kind of sensor because it is not safe. So that's mean all the contact biometric sensor is not relevant during the post COVID-19 pandemics. And also the effects we can see in terms of the company that invest in the biometrics device. For example, the company that produce the sensor to capture palm print or fingerprint, and this company they need to reduce their productions, or maybe they need to stop their productions because of this scenario. Okay. And also for the research point of view, most of the algorithm that we developed before COVID-19 pandemic, we need to do some changes. Okay, for example, facial recognition that we used before this is able to recognize a full area of face region. But nowadays, only half of our face, because when we use mask to cover our face, only the upper part of our face that is available for the recognition purpose. So this is the issue that we want to see in detail for in today's presentations. Okay. Before we go in detail, this is the outline of my presentations. Okay, we want to see what's meant by contact and contactless biometric, and then we want to see the limitation of facial recognition during COVID-19 pandemic. So, of course, one of the popular biometric is facial recognition. So, our case study for today discussion is on the facial recognition. Okay, and then we want to see global versus local features and information fusion, PCA, LDA, Gaussian model, and also the last one is experimental analysis. Okay, this is the overview of biometric. Okay, from the figure that you can see here, okay, we have contact biometric and also contactless biometrics. So as I mentioned just now, contact biometrics means that biometric that directly contact with our skin or with our body, with our body. For example, fingerprint. Fingerprint, one of the example contact biometric. And then we have hand. Okay, hand means we try to use the information center of our hand. We call it palm print. Palm print. So we need, if we have a sensor, and then we need to put our hand on the sensor. This one considered as a contact biometric. And for contactless, is iris, face, voice, signature, and also keystroke. So basically, the biometric traits we can classify into two categories, as you can see in this figure. So the top row is the physiological, okay, physiological biometric, and another group is behavioral biometrics. So based on this diagram, biometric is widely used in security access, okay, border control, depend on what type of biometric that we will use. For example, the fingerprint widely used in for example, to record our attendance, and then the facial recognition is used for border control, okay. And iris sometimes we use for high security application, for example, ATM machines, okay. So the keystroke also one of the very popular biometrics for the ATM machines, signature, and also voice. So the contactless during this scenario, okay, contactless biometrics we can say is more safer, okay, safer compared to contact biometrics, right? Okay. Okay, now, as I mentioned just now, our case study is based on the facial recognition. So you can see from 8 of these images, okay? These images I take from the standard data set, okay? Standard web collected data set. Okay, you can see all of this person, they cover their face with mask. That means only half of their face. So you can see this guy, maybe this guy is a doctor or surgeon. Cover they covered with a facial mask, and then on the top here they cover with plastic. Okay, cover the head with plastic, and then this guy they cover half of his face, and this guy also, this lady is also. So when we see this image, so we realize that we only have very limited area of face to recognize these people. Okay, for example, let's say you want to recognize your friend. Okay, your friend will, let's say he sit 100 meters from you. Okay, 100 meters far away from 100 meters. So basically, when you see his face, you will use the basic shape. For example, mouth, shape of nose, mouth, nose, eye, and everything in order to recognize. So you do not need to look in detail, for example, the skin surface, any marks on the skin, because this is not important for facial recognition. Okay, so when we come back to this situation, when we cover this this area, the important shape of mouth, nose, and everything with mask, that means we have very limited information that we can use. Okay, that we can process by the machines. Okay, that's the challenges that we want to have a look in detail. Okay, let's say we try to zoom one of this guy. Okay, so this is the one of the image number 5 here. Okay, so when we have the image like this, okay, the information that we can extract from this image is the forehead, okay, something like this, and then we also have eyebrows, something like this, and also we have eye, and also the distance between two of these eye. So this is the only information that we have, that we can supply to the machines or to the computer or to the any intelligent platforms to do recognition process. So you can imagine with less number of information like this, I'm sure it's very difficult for the system to get the performance at par as the previous technique, previous method when we have the full area of face region. So this is the challenging for all researchers to overcome this problem. Maybe one of the solution is we need to think on how to develop a very good feature extraction techniques, okay? And also we need to think what is the best classification technique that is able to recognize a person when we have very limited information, okay? So all of this technique we need to see in detail, right? Okay, so now when we talk about features, okay, basically in biometric, we have two types of features. Okay, we have global features and we have local features. Okay, based on the name, I think you can guess what. Global means you take the whole area of face region, this region. When the camera capture your face, so they will be the background image. Okay, and then you need to properly crop the region of interest. Just take this area. So this area we call global features. Okay, and then for the local features means that you can see image number 2. So when we try to divide the image into a smaller sub-block window like this. So in this case, we use a 4-block windows. But in the actual work, there will be a few, maybe up to nearly a few hundred sub-block window. But for this slide, I just put 4 like this because easy for us to understand, right? So when we have the local features like this, we try to divide the image into the local patch or local sub-block window, and then we process the image in each of this window. Okay, so we try to process in sequence. First, we process the features from window number 1, window number 2, 3, and 4. But for the global features, we take the whole image and we process like this. So during this pandemic, so when we cover our face with mask, okay, and then the best features maybe is should be the local features compared to global features, because global features no point, because half of your face, okay, is considered noise or unwanted information. Okay, this area is unwanted information, so no point for us to use the global features. Okay, so the best solution is by using local features. Okay, this is the quite popular algorithm that we can use to extract global or local features. The first is a discrete cosine transform. Okay, discrete cosine transform is widely used in our daily life. For example, if you have a mobile phone, you capture the image. Okay, the image is saved in your folder. Actually, the system uses DCT. Okay, another name for DCT is JPEG. Okay, JPEG. When you save the image.jpeg, that means you use DCT algorithms. So if you save your video, they call MPEG. Okay, MPEG. Okay, another algorithm is a wavelet. The wavelet is very popular for signal processing, for image processing. And then this is another algorithm you can see in the green ellipse here. So Gabo, we call it Gabo. So this is the example of Gabo features. Okay, Gabo features, global Gabo and also local Gabo. And then we have LVP and also DFT. How the system works for the global and local features, we can see this figure. Okay, when we supply the image or when we have the input image to the system, we try to compare your image with the image that exists in database. So by using the global features, so we need to use a feature extraction. So this is the image after we apply feature extraction, and then we use the we need to compare both of these images. So compare in this case means that you need to use a classification techniques, not just to compare using a simple method. When you use classification technique, we have the classification based on statistical learning. Okay, we have a classification based on linear projection technique. So that's mean by the compare process. Okay. So when we have the local features, we need to do the same things. When we have the input image here, and then we need to use the feature extractions that are specific for the local features. So this is the local features that we manage to extract from the image, and then we will use the classification techniques to perform recognitions. So after this, I will show you one or two technique of classification technique that is very popular for in a biometrics recognition framework. All right. So now we want to see what is the advantage or disadvantage of global and local features. So global features require full area of facial image in order to produce rich information. Okay, that means it depends on the full area of face image. And also if you cannot get a full area of facial image, then the performance of global features will drop. Okay, and also global features, the power of discriminations is lower when we have a large variations in the image. For example, the lighting effects and also the orientation. When you want to recognize your face, sometimes you need to give the perfect orientation like this. If your face angle is 10 degrees to the right or 10 degrees to the left, and then the system will fail, or the performance of the system will drop. So this is very common when you use global features. Okay. So now, what is the local features? We want to see the local features just now from the image that I showed you just now. Okay, we have the forehead here. We have the eye, shape of eye, nose, and everything. So we can process this area by using the small block window. For example, we can create a window 8 by 8, or we can create a window 16 by 16. But sometimes the other researchers, they use the higher size of window, 32 by 32. So when you try to process the image into the smaller size of window, so they call it local features. Okay, so the local features is quite popular because the output of local features, for example, when you use discrete cosine transform to process the local features in a subblock window, so we can have two types of data. Okay, one is low frequency information, and also high frequency information. So, okay, high frequency information in biometric we consider as noise. Okay, maybe in other application, high frequency information is very useful, but in biometric technology, high frequency information is considered as noise or unwanted. And normally we will remove from the feature space, and then we just preserve low frequency information. Okay, so this is the characteristic of local features. So we can have a low frequency information and also high frequency information. Okay, so when we have global and local features, what is the best solution, to increase the performance of the biometric system by just based on the global and local features? So one of the most popular technique is information fusion. So we try to fuse multiple information in our system. So in a biometric, when we use information fusion, normally we refer to multimodal biometric. So this is the framework of multimodal biometric. I take it from one of the very popular paper, research articles. So for the information fusion in biometrics, so we can perform at three different stages. Okay, stage number one is feature extraction. Okay, when we have the output of feature extraction, we can fuse this vector. Okay, and then another process to do the fusion is at a matching score level, matching module. So at the matching module, we have very limited information compared to feature extraction. Okay, at the feature extraction, it is considered that the system will produce the richest information compared to matching module and also decision module. And the last stage of information fusion is decision module. At the decision module, we have very, very limited information. For example, we only have 1 and 0. The output of decision module is 1 and 0. 1 accept, 0 reject. So how to decide the final, how to get the final decision is based on the logical operator lah, and or logic. Or if you have 3 level of this, let's say this is 1, this is 2, and another one we have 3 layer, then we can use majority vote. So majority vote try to count what is the highest score lah, given by 3 decision modules. Okay. So this is the basic idea of the information fusion. So with the limited information that we have in facial image, maybe this is one of the solution that we can explore. We can fuse the information. Okay, this information can be taken from global or local features that we discussed just now. Okay, so framework of feature extractions. Okay, when we want to fuse the information at feature extraction, there is several steps that you need to consider. So step number 1 is image pre-processing. So image pre-processing is very important, okay, because you want to find what is the region of interest. If you are dealing with spatial image, the region of interest in this area, the rest need to remove. And another example, if you have the iris, this is the iris, okay. We try to get this the circle in your eye, we call it iris. So we need to have the feature image pre-processing for the iris image. So after we have image pre-processing, we need to use feature extraction. Okay, there are so many type of feature extraction. For example, here we have a 2D Gabor filter, we have discrete cosine transform, and so we have local binary pattern, and then we have histogram transform. It depends on the what type of features you want to use. Okay, if let's say your features is in frequency domain, then you can use a discrete cosine transform or discrete Fourier transform. If you are interested to use features in time domain or in spatial domain, one of the example is Gabor transform. Okay, so Gabor transform can give it's also one of the popular feature extraction in spatial domain. Okay, when we have a feature here, let's say this is the face feature, this is the iris feature, so we can fuse this feature. Fusion means we combine 2 information. Okay, let's say the simplest technique of fusion is concatenate, okay, or stacking. Concatenate means if we have one vector size is 20 and then another vector size is 10, so you just concatenate 2 of this vector, and then the fuse vector is become 30, so you just concatenate 2 of this vector. A very simple process. So if you try to do it in using any programming language, so concatenation maybe just 1 line of code, okay, 1 line of syntax. Okay, another technique is metric interleave. Okay, metric interleave is another technique of still concatenation, but they try to do the concatenation in a different way. So why, maybe you think, okay, what's the purpose of concatenations? Okay, why you need to combine this information? Okay, the reason because when we combine these informations, so we can have a better separation, better class separation in the feature space. So in the feature space, you can imagine like this. Okay, so we finish this part. Okay, so in the feature space we have like this. So you can see class number 3, class number 2, class number 1. So here, class number 3 and class number 2, they are overlapping features. 1, 2, 3. So it's a certain 5 of this group. Okay, this group, they have the overlapping features. So overlapping features like this we need to avoid. Okay, we need to avoid, because if we have a very good classifier, sometimes this classifier will fail to classify this kind of feature space. So that's why we need to apply the information fusion. So when we apply information fusion, okay, we can drag class number 3 to somewhere here, class number 2 to somewhere here. So that means they are well separated, and also there are no data point overlap within their region. Okay, that means when we apply, use this feature space with our classifier, so the classifier will perform will perform very well. Maybe the accuracy can reach up to the top one, 100%, 100%. If there are overlapping features like this, maybe the accuracy very sure will less than 100%. Okay, so that's the reason why we need to apply information fusion. All right. Okay, so now we need to have a look in detail. Okay, data point in the feature space. Okay, data point in the feature space is very important. So you need to understand your data distribution in the feature space. When you know this information, you are able to choose what type of classifier that you can use. If your feature space is well separated, okay, then the simplest classifier, for example, Euclidean distance, can be used. But if your feature space is very compact like this, so you can see very compact like this, so you need to use a very, high-end classifier, for example, based on the statistical method, for example, Gaussian mixture model, hidden Markov model. So this kind of classifier, it based on the statistical learning techniques. So when we use the statistical learning techniques, this kind of classifier is able to model any data distribution in the feature space. Okay, okay, all right. So now let's try to use this figure. I forget to label this figure. Okay, never mind. Okay, this figure we have the input space. So when we have class red and also class blue, this is two different class. So the boundary between two of this class is non-linear. So you can see this is non-linear. Linear means if you have straight line is linear. So otherwise, when you have a curve like this, we consider non-linear. So for this kind of feature space, it's very sure that the performance will not reach up to 100%. Okay, maybe around 80, 90 something. So what we need to do is we need to transform, okay, your data from the non-linear separation like this to the high dimension like this. So when we transfer from 2D to 3D like this, you can see clearly we can separate the blue class and also the red class. So between these two groups, we can create the decision surface. The red layer here we call decision surface. So here decision surface is linear, right? Linear. So whatever data fall upper than this decision surface, we can classify, okay, this is class 1. Whatever data below than this, consider class number 2. Class 1, class 2 refer to person lah. Let's say person 1 is IMRAN, person 2 is Muhammad. So we separate. Whatever data fall upper than this layer, we classify as this is IMRAN, and then below of this is Muhammad. So this is the way how the classifier works lah in biometrics. But the main idea is we need to prepare our data point, try to make it better. We try to make it well separated, okay, between class 1, class 2, class 3, and so on. You can imagine in actual biometric, the person may be up to 1 million, up to 10 million. So you can imagine this is very very challenging task lah in a classifier design. Okay, okay. So now let's move to another feature space like this. So this is another example. Sometimes we need to apply the kernel. Okay, kernel is a mapping from 2D to 3D like this. So when we have a 3D like this, the top here is class 1 and below here is class number 2. So we can see they are clearly well separated. Right. So now we want to see what is the commonly used generating a feature space from the raw data. We have the raw data, or we have original image captured by camera, and then how we can generate the feature space like this. Okay, one of the popular techniques and well-known technique is the principal component analysis, or PCA. So I don't want to go through the detail of this equation. Okay, so we can have a look on the figure, this figure. So let's say this is the data, the raw data that we managed to generate from raw image. After we apply PCA, so you can see clearly data for 4 different classes, they are well separated. So you can see there are no overlap. That means this is good. If we apply this to the matching process, the result will be higher, okay, because there are no overlap data. Okay, another technique is linear discriminant analysis, LDA. LDA also is very popular. I think both of these, PCA and LDA, they use in biometric. I think nearly since 15 or 20 years ago. Okay, for the LDA, the same idea. If we have the raw data like this, so that we try to find a vector that is able to project our data. So at the end, our data will have better class separation. So that means in this case, data distribution like this, so we can have 2 vectors. Vector number 1 in this direction, vector number 2. So if we choose vector number 2, we can have the worst 1D subspace. You can see all of this information are overlapped. All the data point in three of this class, they are overlapped, which is not good for matching process. So we need to choose these directions. So when we have these directions, and then from 2D we can plot to 1D, so we can have a distribution like this. That means this is good for matching process. Okay. So that's why PCA and LDA is very popular, okay, because they manage to do the projections to the lower feature space, that at the end the new feature space will have a better class separation. Okay, that one is for linear projections. If we have more complex data, okay, so we need to consider to use statistical techniques, statistical modeling. So in this case, I'm using multivariate Gaussian mixture model. Multivariate Gaussian mixture model, or normally we call GMM, or sometimes we call Gaussian mixture model, is a very powerful signal analysis. So you can use this model to represent probability density functions of any data distribution. So the idea of GMM is if we have data distribution like this, we try to model this data by using multiple of Gaussian function. Single Gaussian function is like this. Gaussian function, just one ellipse. Single Gaussian function. So now we try to use multiple number of Gaussian functions. That means we try to combine 2, 3, 4, so 5, and so on. So it depends on data distribution. Based on this data distribution, I'm sure the number of Gaussian function not less than 10, maybe more than 10 to 15. Okay, so when we use Gaussian mixture model, so we manage to represent probability density functions for data distribution like this. Okay, this is the formula for GMM. Okay, so if we want to use GMM, okay, if we want to apply a GMM in a biometric, so we need to prepare a GMM model for each person. If we have 1 million person in our system, okay, consider it's very large, so we need to have 1 million GMM models. So each of these model, they have their own statistical parameters. So that means you need to train. In order to estimate these 3 parameters: weight, mean, and also covariance. So these three statistical parameters need to be trained by using for all 1 million people exist in our biometric system. Yeah, so basically the framework is like this. Okay. So what is the advantage of GMM? Okay. I can say here GMM is better compared to LDA and PCA that we discussed just now. Even the complexity of GMM is higher compared to the PCA and LDA. The method that use GMM will guarantee to produce a better recognition accuracy. Maybe it can up to 100%, or maybe less than that, 99 something or 98 something. The reason because they use statistical learning approach. Okay, in machine learning, GMM is considered one topic of machine learning. Okay, that's why this technique is widely used in digital signal processing. And also the probability density functions that we generate from data distribution is able to capture any underlying statistical information exists in feature space. And the most important thing is GMM is able to work together with local features. Local features that we discussed just now, okay? We divide our phase region into smaller block. So this smaller block is related to the GMM input. Okay, this is the experimental analysis. Okay, I have 10 minutes to stop the presentation. Okay, this is experimental analysis. So we can see clearly this analysis, the first analysis is based on the LDA and also PCA. So we can see from the analysis here, the top here is by using LDA, linear discriminant analysis, and also local features. When we use 9 training images, then the highest performance can reach up to 90. This is the case when we cover our face by using face mask. Okay. And this is the analysis of GMM, okay, Gaussian mixture model. So by using Gaussian mixture models, the highest performance is 96 something. We cannot reach 100%, okay, because of the limitation, because of the variations exist in the image, okay. So the highest performance is by using information fusion, DCT fused with LBP. So we combine two different features lah, LBP combined with DCT, and then the fused features, okay, we use to train GMM models, okay, GMM models. So you can see the number of GMM component, 18. What's mean by this number? 18 mean you have 18 normal distribution shape, 18 of this circle, okay, 18 of this circle. That means if this circle is higher, that means you manage to properly model whatever distribution that you have. Okay, so when you have 2 here, that means you only have 2 circle of, or you have 2 Gaussian distribution, or 2 normal distribution, or 2 circle. That's why the performance is low. Okay. Okay, another experimental analysis. When we deal with local subblock window, okay, smaller window, sometimes the overlapping features also important. For example, from window number 1 and window number 2, we need to overlap them. For example, overlap within 10% pixel, overlap 25%, or overlap 50% of the window. So overlapping window overlap will give a better performance. So you can see when we have the red line here, so this is window overlap by 50%, and when we have the sub-block window, size of our window is 40. So the top performance or the highest performance is 96%. So here when we have a 10% overlap window, the performance is lower, even if we try to increase our sub-block window size, okay? Okay. So now, what is the future study? So now, just now you see we need to generate a better feature extraction techniques, and then we need to come out with the classification technique that is able to deal with very limited information. So for the feature study, you need to think what is the best feature extraction technique with limited facial area and limited number of training image. So when we have limited facial area and also we have limited number of training, only one face that we give to the system for training purpose. So we need to think what is the best feature extraction. Maybe we need to apply information fusion, or maybe we need to come out, or maybe we need to enhance the existing feature extraction techniques. And for the feature study, you need to think on how to utilize a limited data point in the feature space. So when we have limited data point, at the same time, we need to avoid overlapping. So overlapping in the feature space will reduce the performance of the system. So how to overcome this problem? Okay, this problem. I think that's all for my presentations. Thanks for listening. So if you have a Q&A, so please, we can proceed with Q&A session. Okay, thanks.
Okay, thank you, Associate Professor Dr. Imran, for very informative presentation. Okay, now I open Q&A session. So all participants can ask directly, or you can write your question in the chat room or chat box. So any question? All right, it's okay. Dr. Imran,
Yeah.
I have one question here.
Okay.
What is the future for biometric in our country?
Okay. Future of biometric in our country, I can say like this. Okay, after COVID-19, the future of biometric is very high, because we can use for example, the problem with social distancing. Social distancing is very difficult to monitor in the manual approach. So we can use biometrics. We can have a overhead camera to capture the social distancing practice in our country. And also maybe contact tracing or human tracing. So nowadays we go to the shop, to the mall, you need to write your name using the MySejahtera apps. And sometimes if you don't have the mobile phone, you need to write on the logbook. So this is very time consuming. Sometimes you need, if your name is long, for example, my name is considered very long, you need to wait up to 1 minute to write the name. So if you can apply this technology, if you can implement biometric to solve this issue, I think it is better. Okay.
Yeah, thanks, Dr. Imran, for, I think that's a good answer lah. Okay, related to the first question, okay, how can we guarantee the security and accuracy of biometric?
Okay, I think this is very nice question. Actually, I forget to highlight in my presentation. Actually, in biometric, the security is very big issue. So you can imagine if you give the thumbprint, you record a thumbprint, okay? So this thumbprint, let's say if someone try to hack this image, so you will get a big trouble. They can use with so many purpose. So that's why in biometric we have cancelable algorithm. We call it cancelable technique. So cancelable algorithm means that when the biometric capture your fingerprint or your thumbprint, so before they record in database, they try to transform raw data to different representation, or we try to transform from one domain to another domain, and this domain, okay, we cannot generate the original texture. That means once we transform this, so we cannot see the actual biometric features. So this technology, they call it cancelable biometric, and also very popular in a biometric research area. So it's okay, Dr. Imran?
Okay, thank you, Dr. Imran. Okay, if you can check your chat box.
Chat box, yes.
We have one question.
Dr. Zuraida,
Yes.
Dr. Zuraida asked, when to use 2D Gabor filter, what is the feature that can be extracted? Okay, right. This is a Gabor transform is very popular in biometric. Okay, since we are dealing with face image, so we need to use 2D Gabor. Okay, 2D-dimension Gabor. So the features is after we transform by using Gabor, So we will get another image we call Gabo image. So this Gabo image carry a very important information compared to the raw image, because in Gabo we have different orientation. How we scan is like this lah. We scan in 360 orientation, and also we can scan the size of the. We can scan the information with a different size. They have the something like the Gaussian or the Gaussian function that we can control the variance, or we can control the size of a Gaussian shape. So we will get a better information compared to raw image. But the drawback of Gabo is, let's say your original image is 100 by 100. When you use Gabo, maybe the image become 10,000 by 10,000. It's very big. Then you need to have very powerful processor lah, in terms of a processor, in terms of memory, to process Gabo image. If a low cost processor, I think you will get a problem. So this is the limitation of hardware. I think I hope I answer the question. We have another question. Age effect to face recognition by Dr. Azrani. Ask age effect to face recognition can detect registered face in the next coming 10-15. Okay, this is another challenges in facial recognition. So we consider age as the variation. One of the variation in face recognition is age. Okay, with very limited informations, this will be a big problem. Let's say now your age is 20, and after 20 years your age is 40. I'm sure the basic information will change. So if we have this kind of data in our database, maybe the system will fail to recognize at the high rate. At the, let's say we expect the system is 95%, and for this kind of image maybe it will drop to 60 or 50 something. I hope I answered the question. We have another question by Dr. Amir Nazrain. What is a minimum processor and memory requirement to run GMM? This is very interesting question. Okay, GMM is very powerful. You can use everywhere in your life. Even you can use in industrial informatics. You have the machines produce the vibration. You can tap this vibration, then you can decide is there any defect on the machine or not. So the same idea we bring it to biometric. Before this, they use GMM for speech recognition, speaker recognition. Speech means the system that is able to recognize your speech. If you say hello world, then the system will understand, okay, this is hello world. If you say, my name is Imran, and the system will understand, oh, tell us that your name is Imran. So this is speech recognition. Speaker recognition is another technique that try to differentiate different people based on their speech. Okay, for GMM, they manage to do all of these tasks. That means they are very powerful and also very time-consuming process, and the algorithm is very extensive. So you need to have very powerful processor. For the minimum, I can say before this we use i3 processor, still can. Okay, i3, i5 very sure also can. i3 processor also can, but lower spec processor is depend on your input. If your input is image, yes, low spec processor can. But if your input is a vibration signal and something or speech signal, then the system will not able to proceed with the algorithms. So I hope I answered the question, Dr. Amir.
Doctor.
Yeah, Wassalam.
I have one question. I didn't quite understand when you there's one slide regarding sub-block window that you show. Yeah, I don't understand why is it the higher window overlapping give a better performance in that case.
Okay.
Thank you.
Ini soalan dari Farhan, eh?
Yes, I.
Okay, all right. For the local features, okay, local features, we expect that we will use a smaller block of window. Smaller block of window, let's say our window is 10 by 10, okay, 10 by 10. So when we apply window overlap, okay, actually we try to integrate, okay, dependent information. We try to integrate, for example, window number 1, what is the information that related to its neighbor? That's why we try to put the overlap. Because this dependent information is very important in statistical learning. If we treat local window as independent means you do not need to apply the overlapping process. That means one window with another window, they can be, they do not need to overlap. That means two of these vector we treat as independent. Okay, so when we have the independent vector like this, the statistical relationship between window 1 and window 2 is lost. So that's why the overlapping will give the better performance. I think most of the paper, when they use speech recognitions, they discuss this issue very well.
Thank you, Dr. It's very clear.
Thanks. We have Bapak Eko Praja from Indonesia. Okay, the question is, talking about biometric definitely goes hand in hand with security, but what about the case of identical twins from the security papers? Yeah, this is very, the challenges in the facial recognitions. Twin, let's say they have two people have the same shape of face. I can say here the biometric facial recognition will fail for this kind of problem. Even if you have a father and son, okay, father and son nowadays they have very similar face. For example, we have many father and son, they have very similar face. This one also another issue. Okay, the system will fail. So in order to tackle this issue, we need to think. We need to think on multimodal biometrics. We need to integrate multiple biometrics. For example, face with iris, because iris is very unique. Iris is your eye. Okay, if you are twin or if you father and son, you will have a very unique iris texture. So this is the only way that we can solve for this issue. And we have another question by Suhaizal. How the consistency and stability of light source during each photo section and throughout the process affect accuracy? Okay. The light source is considered one of the variations in facial recognition. Let's say if you put your camera in front of the sunlight, and then tomorrow you take again in the room, the system will fail. So we need to have a very consistent light source for us to do the recognition purpose. And normally for the setting of the facial recognition, we have the standard, not standard, we try to make it, we try to use the LED, okay, with our camera, so we can have constant level of light for training and also for testing purpose.
Okay, thank you, Dr. Imran, and thank you all for the active Q&A session. Okay, before we end this webinar, don't forget to fill out the registration form, and you guys can download the slide presentation through the link we share in the chat box. Okay.
Okay, thanks everyone. So before I stop my presentation, before I stop my discussion, I would like to say again, thank you very much. And so we have the participant from overseas also, Iraq, from Indonesia. If you want to in the field of biometrics, so you are welcome. Okay, so maybe you can contact me if you want to know further.
Okay, thank you all. So I hope we can meet to next webinar series. So take care. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.